Hello everyone, here it's Mr. Kablan here once again, and today I'll be only looking at one shape, okay? However, I'm going to be looking at both surface area and volume of that one shape here. So before we begin, just refamiliarize yourself with our formula sheet here. So take it out. So today we will be looking at a cone. So if you look on the right side there and the third shape down, okay, you can see the cone is right there. Okay, and we'll be looking at the surface area and volume of a cone here. Now, again, please have it handy because you're going to see that when we're dealing with a cone, okay, there are going to be some calculations we have to do in between before we put numbers into a formula. So it's important that you see that when you're given a cone or any shape for that matter, that you see what information is given to you and the series of steps required in order for us to solve the problem. All right, so let's take a look at surface area and volume of cones. All right, so when you think of a cone, it's exactly what it is. Okay, it's a cone, and when we're looking at the surface area of the cone in particular, and you're looking at the formula from it, okay, what we have to see again is that it actually consists of two main faces, okay, and the two faces are the circular base, okay, and the lateral area. Now, when you're given the formula over here, okay, you can see that if you break down the formula to the two different parts, okay, the one familiar part for the formula, as you can see, is pi r squared. So that would represent the area of the circle there. All right, so when you're looking at the lateral area, okay, this is the actual cone part. Okay, so if you think about for example, an ice cream cone without ice cream in it, okay, that part of the formula would represent that part of the cone. Now, once you have a cone and you seal it, okay, and then you would include the area of the circular base, okay, which I'm going to indicate there in green, okay, and that's going to be the pi r squared. Now, with cones, okay, inside the triangle, you notice that there's a right angle triangle there. So that's why in some cases, if you are missing either the height, the radius, or the slant height, okay, you do need to use the Pythagorean theorem to solve for one of those measurements. And for when you're given the information, you will be given two out of the three measurements there. All right. So just remember that when you see a problem like that. Okay, and again, you will be seeing Pythagorean theorem again in this lesson here, so just know when to use it and how to use it for the cone. Now, the volume of a cone, and in terms of one of the lessons I taught earlier, if you do recall, when we did the cylinder, okay, the formula for a cylinder was pi r squared h. So what you need to know about that and how it relates to a cone is that the formula for the cylinder, okay, I'm going to outline here in red, is the top part for the volume of a cone. So what that means here is that all of cone is the volume of a cylinder, okay, and then divided by 3, or a third of the volume of a cylinder. Okay, so that's how the cone and cylinders are related. That's why cylinder was taught first before the cone. All right, and again, just like I mentioned in the previous slide here, if you are missing either h, r, or s, you will be using Pythagorean theorem to solve for that unknown length. All right, so let's get to it here. And what we want to do here, again, is to calculate the surface area of the cone first. Now, if you take a look at your formula sheet here, and this is a good way to come up with a strategy to solve surface area and volume problems dealing with any shape here. Okay, if you take a look at the formula for the surface area of a cone, I want you to take a look at the numbers in this screen here, as well as in your sheet, your notes, okay, and see what measurements you have and what you don't have. And the reason why I'm asking that, because if you take a look at the 4.5 and 6.0, and you look at the formula for the surface area of a cone, okay, you will notice you are missing something here. All right. So if you notice that you are missing the slant height, you're absolutely correct. So our very first step for this question here is actually to solve for that using Pythagorean theorem. So that 6.0 there represents the height or the vertical height from the top of the cone to the bottom of the base here. Okay, so you're going to see that I'm going to draw a right angle triangle inside and then just blow it up so you can see it. Okay, so from here, okay, notice that what you have here is the letter C here, okay, which is the hypotenuse, which will then become the slanted height of the cone here. And then what you would have here for the 4.5, that would be your A, so you're solving for the B, okay? So by doing that, when we put the numbers in, okay, we're going to take the 4.5 and square it, and the 6.0 and square it, add the two numbers together, and then take the square root of both sides. So that's going to give me a total here of 7.5 centimeters. All right. So now that we have that, we now have all the measurements for the surface area. So next thing, use a formula, put the numbers in. Okay. Now you notice that what's happened here is that the radius here is the 4.5 because the radius is the center is the distance from the center of the circular face to the edge of it. Okay, and even though we labeled it as C for the Pythagorean theorem, for the formula for the surface area of a cone here, that 7.5 will represent the S or slant height. Okay, and when you put those numbers in your calculator, again, don't forget just to make sure you put it in carefully. You should get a value there of 169.56 square centimeters. All right, so that's surface area. Now, since we've already solved for all the numbers here, then for the volume of it, okay, we just pretty much have to just put the numbers that you see on the screen. So the radius, as I said before, is a 4.5. Okay, and the height here, again, is the height that's inside the cone. Okay, so if you take a look at your formula sheet, you can see that right away. And when you put the h there, that will be 6.0. And when you simplify that, that should give me 127.17 cubic centimeters. All right. Now I broke it down step by step in this on the screen here. However, if you do the top part here, pi and then 4.5 squared in brackets, okay, and then 6.0 in brackets, divide all by 3, you could also get the same answer in the next step there. So again, choose what's comfortable for you. All right, so that's the surface area and volume of a cone here. So what we want to do now is to use a word problem and be able to think of a strategy to solve the problem here. So in this question over here, we have to find the height. So it says here, a fountain firework is packaged in a conical container. Its volume is 300 cubic centimeters and its diameter is 8 centimeters. So what we want to do here is to find the height of the fountain work here. All right, so step number 1 over here, we don't have a diagram. Okay, and unlike the previous two examples, we're not solving for surface area and we're not solving for volume. However, we do need to use one of those two formulas in order for us to solve this problem here. Now, when you're reading a word problem, it's very important to see exactly what is given to you because writing down the formula in the very first step is very critical to getting the correct answer. So if you take a look at this question over here, okay, you notice what we have here is a volume is given. So since volume is given, what we have to do there is now write down the formula for volume of a cone, okay? The next thing we want to do here is to put that 300 in for the V and see what else we have. All right, now we have a diameter of 8 centimeters. We got a problem because we want radius. So remember, diameter is the entire distance of the bottom of the circular face. So in order for us to find the diameter or the radius, which is half of from the half of the circular face to the edge of it, we just need to take that divided by 2, and that's going to give me 4 centimeters. All right, and that's going to replace the R. Okay, now in the next step over here, we're just going to replace those letters with these numbers. Okay, and the next one we're going to do here, we're going to take the 4 and square it, and that's going to give me 16. Now, when I write down 16, okay, remember all numbers have to go in front of all the symbols and letters, so we're going to have something that looks like this. All right, now going back to solving equations here, we're going to follow the exact same steps. So the next thing we want to do here is to get rid of the fraction. So remember, you always get rid of a fraction by multiplying both sides by the denominator. So we do that. We multiply both sides by the denominator, and it cancels out the 2 3s on the right side here. Okay, and we're left over with 900 is equal to 16 pi h. All right, now, since we're solving for the h here, what we need to do here is to isolate it. Now remember, the 16, the pi, and h are grouped together by multiplication. So what we have to do here is we actually need to divide both sides here by 16 pi. Okay, and when we do that, the 2 16 pi's cancel out on the right side, and then 900 divided by 16 pi is going to give me 17.9 centimeters. So the height of the fountain firework will be exactly that. All right. Okay, so that wraps up another shape here, and I will see you in the next lesson.